Hello, everybody. This section is 5.4, and now we're going to see the derivative for exponential functions. And we'll start with this rule number one for the exponential function with base e. Its derivative is the same thing, all right? So if you have ex prime is ex, which means the same as the derivative with respect to x. So let's look at some examples. If we have x squared times ex for f of x, this is a product, so we'll use the product rule, which is x squared times the derivative of ex plus ex times the derivative of x squared, which will lead to ex as a common factor for x plus 2. Because you see here the derivative of x squared is 2x, and that leads to that. So this form or the other is okay. X squared ex plus 2x ex. For this here, of course, you'll see that for this g of t, we have this form. So you're going to keep in mind the chain rule. So you're going to do the power rule first and keep in mind the chain rule, which is the derivative of the inside. So we do 3/2 times this and minus 1 for we get 1/2 times the derivative of the inside with respect to t. The derivative of et with respect to t is et. The derivative of 2 with respect to t is 0, and that's going to give us et here. And that's it. So that gives us that. So applying the chain rule to exponential functions would lead us to rule number 2. It's a nice formula that is applied for exponential functions, and it uses the chain rule in it. So e to power ef to power fx, you just do e power fx times the f prime of x, which is that derivative of the inside for the chain rule, and that's it. So which is the same. So this is, as you see here, this first part here is the same, multiply the derivative of the exponent. So here is an example, e to 2x, so it's the same, times the derivative of the fx. Fx here is 2x, which is 2. Same thing here, that's same, the derivative of negative 3x. And a similar thing we'll do for this one, and its derivative. Okay. All right, so the 4t plus 1, because you differentiate with respect to t. So let's look at some examples from the homework 5.4. Let's look into maybe number 3. They are going to run into the same way, and if there is some applications we will do in class. So f of x, ex plus 6. And in this case, you're going to use the quotient rule for this derivative. You're going to do the denominator times numerator derivative plus the denominator, right? Derivative times the numerator there, right? This way. And this one is going to be squared. So f prime of x is going to be, let's just do one at a time. This is the derivative is just ex, and this one is not plus, it's minus, right? And that's going to be ex, and the derivative of ex is ex. The derivative of 6 is 0. So ex plus 6 squared. And that's going to give us, let's break it apart. Ex squared, which is 2x, this one plus 6ex minus e2, 2x, ex plus 6, 2, so 6ex. All right. Let's look into number 4. F of x is 7 minus e2, let's say negative 6. Yeah, so just remember the chain rule. A 6 times a 7, 6 minus 1. Then the derivative of the inside, which is going to be, this one is going to be this. And you're going to ask now, let's do this one at a time so you see this part here. We're going to do the derivative of this inside. So what is that on the side? Let's do on the side. It's going to be 7 derivative minus e, this derivative, right? So that's 0. And now you have a negative, and remember this fx, so it's going to be the same thing times the derivative of this one, which is going to be negative 8. So negative and negative, that's going to give us positive. So for this part here, you're going to put this part here. So f prime of x is 6 times 8 times this times whichever order is going to be okay. So 48. Right, let's look into example 8. Let's say we have h of x is x squared minus 9, and we need to find the derivative. So now try it and see, because e to x squared, it should be the same. I should write, let's rewrite it nicely so it's not ambiguous here. This way. So it should be the same, right? Times the derivative of the top here, which is going to be 2x, right? So 2x times e, that's that. Now, when does this derivative equal to 0? So we want to investigate some stuff here. Of course, when you do this, so for practice, you see the 2 cannot be 0. This part here, e, it's like let's say a number 2.7, just to understand it that way. To power something, a number there, it's not going to be 0. It's either going to be a fraction, Even if x squared minus 9 equals 0, it's going to be 1. So this happens when x equals 0. Let's investigate some numbers. Let's find h of 0. Well, h of 0 means 0 squared minus 9. It means e to negative 9, which is 1 over e to 9. How about h of negative 3? Well, it's going to be negative 3 squared. It's going to be 0, which is 1. So it's interesting. Let's look at 3. Same thing. So based on what we did in the past, does this have absolute extremum? Does it have, or does h of x have absolute extremum in negative 3, 3? Well, if you look at it for negative 3 and 3, for negative 3, you have a value of 1. Let's say this is 1, right? And for 0, which is in between, here it has a value of 1 over e to power 9. If you do that, it's not going to be, it's going to be a really small number, right? It's not going to be bigger than 1 because you're dividing 1 by a big number. So in this case, it looks like the absolute, let's write it here, the absolute maximum is 1, right? Which happens at x equal negative 3 and 3. The absolute minimum is 1 over e power 9, which happens at x equals 0. Okay. So this is, you've seen this now a few times, and we've done different ways. If we're just looking into the absolute max or min, and we've done tests, first derivative, second derivative, and we also did the investigation using the interval values and comparing them. Cool. Thank you.